In this question, we have to show that any positive odd integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Okay. Now, to prove this, we assume that a is equal to any positive integer, b is equal to 6. Okay. On applying Euclid's division lemma, we can write a is equal to 6q plus r, where r is going to be less than 6 and greater than equal to 0. Okay. So we can write this. Now, if r is equal to 0, then a is equal to 6q plus 0, that is equal to 6q. Okay. If r is equal to 1, then a is equal to 6q plus 1. If r is equal to 2, a is equal to 6q plus 2. R is equal to 3, a is equal to 6q plus 3, r is equal to 4, then a is equal to 6q plus 4. If r is equal to 5, then a will be equal to 6q plus 5, and we have written here all the possibility for the value of r from 0 to r is equal to 5. Okay. Now we see here that a is equal to 6q and r is equal to 0. So this gives me an even number. Similarly, a is equal to 6q plus 2 can be written as 2 times 3q plus 1. So this number divides 2. So this is again an even number. And similarly, when r is equal to 4, we can take 2 common here. So we can write this as 3q plus 2. So this number 6q plus 4 can be divided by 2. So it is an even number. Okay. Then when r is equal to 1, a is equal to 6q plus 1. So clearly it is an odd number. Similarly, 6q plus 3. 6q is an even number. 3 is an odd number. So this will be an odd number. And similarly, when r is equal to 5, 6q is even, 5 is odd. So we are going to get an odd number. Okay. So when a is equal to 6q plus 1, 6q plus 3, 6q plus 5, we get odd numbers. Okay. So in the question we were given to prove that any positive odd integer is in the form of 6q plus 1, 6q plus 3, 6q plus 5. When we have taken all the positive numbers, so we get 6q plus 1, 6q plus 3 and 6q plus 5 as odd numbers. They represent all the possible odd numbers. So this shows that all odd numbers, all positive odd integers can be written in the form of 6q plus 1, 6q plus 3 and 6q plus 5. Okay.